So we'll start with stereochemistry. The basics already I have given you last time, that is when in my first lecture, where we have seen how to draw the molecules in a three-dimensional fashion. Okay, and let us recollect what we have talked that time. Yeah. Now see here. Let's see whether you can. We are just trying to recollect what we have done in the first lecture. Now here is a molecule which I have drawn. This is, tell me what molecule is this? Now look at this molecule and tell me what is a molecule. Write the name of this molecule and draw the structure, three-dimensional structure. Write the name of this molecule and draw the three-dimensional structure. Draw this the way you are seeing from the front. This we have done. We have done this before. Here, whenever we draw, what we do is we draw two bonds in the plane of the board, and one of them come towards you and the other away from you. Okay, so this one is pointing towards you, and this one is you can see it is away from you. So that is a convention which we draw. Let me do that. Let me share the screen with you. Oh, what is this? One second. Let me share the screen with you. Come on. So let me take the next next page. I can take the sixth one. Oh, seventh one. Okay. Yeah. Now see here. Now you can see the molecule and draw. This is what we have drawn in the first class. That is, I have the carbon, a hydrogen, which is on the top, and then at 120 angle, I have the second carbon, the second hydrogen. Then this is a bond which is towards you, and very close to it, you have to draw the next one that is away from you. Now, ideally, this angle is 120 in the plane. When we draw it in the plane, ideally, this is also 120, and this also is 120. When we draw in the plane, and this angle is supposed to be 0. This is 0. Why? Because this one of the hydrogen is being eclipsed by the other one. Eclipsed means one behind the other. You cannot see this bond. You cannot see this bond. And this one is projecting towards you. Projecting towards you. And these two bonds are in the plane of the board. In the plane. Now this picture very clearly tells you how to draw molecules. We have done all this stuff. Okay. Now, so that is now see here. Now, let me convert this. That also we have done. Let me convert this into ethane molecule. Okay, try to draw this conversion of this CH4 into an ethane. Here's the H. conversion of this into ethane molecule. You just put a CH3 here. Replace one of the hydrogen with a CH3 and then expand the CH3. So the structure will be like this. Same structure, but here one line is already on the plane of the board, and now the second structure, the second line will be 120-degree angle, and that will put wedge, and then dotted line. Always wedge and dotted line should be side by side, and this is down. Okay. Now let me make a model of this. Yes, it's here. See this. This is the molecule. I should hold it like this. I don't know whether, in which way you are going to see that. Now see this bond, this hydrogen, and this hydrogen are opposite side. See this. The two hydrogen which I am holding, they are in the opposite side. One is a down hydrogen, the other is a up hydrogen. Okay, and these two are up hydrogens, these two are down hydrogens. And you can see here, this one is projecting towards you, this is also projecting towards you. This is away, this is away. And now what you have to do is, we have to, I don't know whether these also we have done. If you draw this is what I have drawn on the board. This is what I have drawn on the board. Now what you have to see is, look from here. Look from here. Keep your eyes here and observe like this. See, observe like this and draw. If you look from here, you can see this carbon, this hydrogen, this hydrogen, this hydrogen, this hydrogen, this hydrogen, all these hydrogens, and this carbon you can see. You cannot see this second carbon. You won't be able to see the second carbon. So how do you represent this structure? We represent by a circle. What is this circle? The front carbon. This front carbon is a circle given. Now if you are looking from here, this bond is exactly down. So let me start from the center of this. And it's exactly down. Then this is, if you're looking from here, this is on your right side. So I have drawn on the right side. And the other one on the left side. Now see here, I have joined all these three in the center. I have joined them in the center. Representing these three hydrogens are closer to you. You are looking from here. You are looking from this side. You are looking from this side. So these three hydrogens are closer to you. Yeah. Tell me, Tashrifa, what happened? Tashrifa. Yeah. Any problem? Are you able to hear? Oh, all right. Now, one second. Now see here. So these three hydrogens, are closer to you. You are looking from here. So they are these three are closer to you. This carbon is closer to you. So that is why I have drawn this in a circle moving to the center. Now these three hydrogens are You can see this is exactly up. If you are looking from here, this is exactly up. See here. And then this one is on the right hand side. This, if I am looking from here, this is on my right hand side, maybe on the left hand side for you people. Anyway, let me write it the way I am seeing it on the right hand side. And this hydrogen is on the left hand side. If I am looking from here, it is on the left hand side of mine. I think it should be the same for you also. See here. Okay, now you observe this. Is this the figure you are seeing from the front? See that. See? Now look at that figure. The same thing which here I have drawn. It's the same thing which I have drawn. And you can see here these hydrogens are maximum distance away from each other. Now let me rotate this molecule slightly, about 60 degrees. Now let me draw this molecule. Now what is the difference? I have rotated one of the carbon. I did not do anything else. I did not break any bond. I have just rotated one of the carbon. How do you get it? I have my carbon, the back carbon, I have kept it here as such. H and H, and rotated only one carbon. So this hydrogen is coming down. And here also it's coming down. And the second one hydrogen is on the top. Now you observe from here. If you observe from here, you can see this hydrogen and this hydrogen in the same line in the plane of the board. You cannot see this hydrogen. So we will draw only these three. You can see only these three. So I will put a circle, hydrogen, hydrogen, and hydrogen. And behind each of these hydrogen, there is the carbon, the hydrogen which is on the second carbon. Okay. Let's put it here. Yeah. Now you can imagine this. So here is, and this form, you can see these two hydrogens are very close to each other. And there will be interaction. Farthest away. Hence more stable. Closest. Least stable. And this way of representation is known as Newman projection. Newman projection. Okay, and this is this when the hydrogens are maximum distance away, it is called staggered conformation. Staggered. Eclipsed conformation. Eclipsed conformation. Okay, the word conformation we have already discussed. Conformation means different view of a molecule. Different views of a molecule obtained by rotation by rotation of a single bond. Rotation around a single bond. Okay, so this is conformation. Different views of a molecule obtained by rotation around a single bond is known as conformation. So conformations are for the same molecule. It is something like I am being seen from the front or from the back side. I remain the same. Okay, so that is what is. So these two are the conformations of ethane. Now let us do an exercise like this. See here. I take the eclipsed conformation of ethane. Remember, this is the most unstable one, meaning this is the maximum energy. This is a form in which the molecule is having the maximum energy. Now what I will do is, I will mark this back hydrogen 1, 2, and 3. And the front hydrogen as 4, 5, and 6. Okay. Now what I'm going to do is I'm going to rotate it. Slowly going to rotate by 1 degree, 2 degree, 3 degree, 4 degree. Like that I'm going to rotate. And study the change in energy by this continuous rotation. Okay. Now I'm going to rotate which one? The back carbon. I'm going to rotate the back carbon only, keeping the front carbon intact, same way. So my rotation is clockwise. So, and remember, this is 120 degree angle, this is 120 degree angle, this is also 120. Okay, now I'm rotating it. I rotate this by 60 degree. Here is my 60 degree rotation. Or the hydrogen. So I have my H1 here, H2 here, and my H3 here. So this is 60 degree rotation. Okay. Now see here, H4, H5, and H6 are remaining the same. H4, H5, H6. Now remember, you cannot distinguish between these hydrogens. All the hydrogens are equivalent. I have just put the number for our convenience. So this is what you get. Now this is most stable one. Least energy, most stable. This is the most stable one. And this is the least stable one. Okay, so this will be having maximum energy, this will be having least minimum energy. Most stable means least energy. So let me draw a graph. I will draw a graph. This is your energy versus angle of rotation. Angle of rotation, or it is also called dihedral angle. It's also called dihedral angle. Okay. Now, as we have seen, you have this having the maximum energy. So we have started with 0 degree. Then we have gone to 60 degree. Okay. Now, from 0 to 60, the energy is decreasing, stability is increasing. So at 0, suppose you're having this energy, at 60 it comes here. Oh, sorry, slightly different. And then it goes up. Okay. So this is 60 and this is 120. So up to 60 degree, the energy decreases, stability increases. But from 60 onwards, it goes over here to 120. The stability again decreases, energy increases. And that is what here. This is 120. Now again, what do you do? Decrease this. Rotate it again. From 120, you rotate it again. Let me draw it. Let me draw each one of these structures. That is quite important. You don't require this stuff. Okay. Now let me draw the from 60 to 120. So this goes to, again you get the next eclipse conformation. Here is hydrogen, there is hydrogen, there is also hydrogen. Yeah, you get exactly the same as 0. So this is 1, this is 2, and this is 3. So 1, 2, and 3. So it has come to the original situation. That means you will have the same energy level as that is 0. Now it goes here further to 120. Sorry, 180. H1. So if you continue this rotation, up to 360 and mark all the bonds here, all the energy levels of this molecule, you can see a graph like this. Okay, so this is 120, this is 180. And note that the energies are same. Should come down. Energies are all same. So 180, you have 240, 300, and 360. Okay, so this is 120. Oh, I have written here 240, 300, and 360. Okay, so this is this plot. This plot is known as conformation analysis. Conformation analysis. of methane molecule. Conformational analysis of ethane molecule. Sorry, ethane molecule. Okay, you have two conformations, staggered and eclipsed, which are having minimum and maximum. Now remember, number of conformations possible for ethane is infinity. Out of this, see, this is a conformation. Here is another conformation. Here is another conformation. But out of this, you have maxima for the eclipsed, fully eclipsed conformation, and minimum for the totally staggered conformation. That is the meaning of this. Now, what you can try to do is draw the conformation analysis of propane and compare the graph with that of ethane. Compare the graph with that of ethane. Okay, compare that with that of ethane. And also the second one, draw the conformation analysis of N-butane. Viewing the molecule along C2 C3 axis. Okay, so based on what we have done, please draw these two figures. And the first figure, you have to compare this graph with that of ethane. In the second figure, you will get different maxima and minima and draw the structure and send it. Okay, so what you have to do is, please send this figure before my next class. Right? Send the answers. Please don't draw by looking at the paper in your textbook. Take it from your mind. Imagine yourself and draw the figure and send it to me. Okay. Now tomorrow's class I want to conduct at 9 a.m. I will not be free at 12. Okay. So 9 a.m. we'll have tomorrow's class. And if possible, let us see whether we can bring the class a little more earlier. 12 looks to be a little bit odd today. So after tomorrow, we will see whether we can conduct the class at 10 a.m. or if possible 9:30. Okay. Thank you.